Welcome, mathematicians, for another lesson in scientific notation. Today we are going to convert whole and decimal numbers into scientific notation. And the last lesson I introduced you to what exactly is a scientific notation type number and what we have to have in order to get there. And one of the elements for scientific notation is one of the factors has to be 10 raised to some power. And you might have wondered why 10 and what are we really doing raising it to a power? So I want to start out by just doing a quick little review on a few of our exponent properties that we learned many units ago. These are the exponent properties that we're going to be using. First of all, anything raised to the 1 power is itself. Okay, and anything raised to the 0 power is 1. So these are two, and you can see examples over here, properties that we are going to be using. And here's one more that's going to be really, really important when we get into tiny numbers, as I mentioned before. Anything with an exponent that is negative. The number itself doesn't become negative. What happens is that negative sign means flip it, put it in the basement of a fraction, okay? It becomes the denominator. And it takes with it a positive version of that exponent, okay? Just like here, x to the negative 3 becomes 1 over x cubed, okay? And you can see how we do that. So I want to show you what happens when we do that, use these, and what happens with the powers of 10. All right, so the positive, we're going to start out with positive exponents, and here's what happens. 10 to the 0, of course, is 1, just like everything is. If we take 10 to the 1 power, we get 10. Next will be 10 squared, which is 10 times 10. That gives us 100. And 10 cubed gives us 1,000. Notice what's going on here. Starting at 10 to the 0, we're at 1. The decimal point is right there, where I've got my little pointer. Starting, and then going on to 10 to the first power. We're starting with 10, okay? And it only has, if you think about it, 0, 0 zeros, 1 0. Here we go. 2, we've got 2 zeros. Raise to the third, we've got 3 zeros, and so on and so on. 4, we've got 4 zeros. So we are literally moving the decimal point. Starting at the 1, we are moving it the number of places that the exponent is. And notice with the positive exponents, we're making the numbers bigger. Okay, we're making them bigger. So anytime you see 10 to the 4th or 10 to the 100th or whatever it is, you know it's going to have that many zeros or places that the decimal point is going to move. So what happens if the exponents are negative? That's where that negative exponent rule comes into play, okay? We're flipping it and putting it in the bottom of our fraction as the denominator. So what I've done here is show you, here's 10 to the negative 1. If we flip that and put it in the bottom, 10 to the first in the denominator, right? Looks like 1 over 10, or we can pronounce this 1/10. So think of it that way. We're pronouncing it 1/10. This is the 10th place value. So we've got 1/10 is 0.1. So when you see it to the negative 1, the decimal point is in front of our 1. We've moved over to the left. Now what happens if it's negative 2? Same thing, we keep on moving. We start here at the 1 and we go 1, 2. We're moving to the left. We're making a smaller number. The bigger our exponent here, the smaller our number gets when we have the negative exponent. Okay, so you can see 1 over 10 squared is really 1/100th. And that's what this is, 1/100th, because we're in the 100th place with that 1. So negative 3, of course it moves it 3 places. Now keep in mind, we've moved it 1 place to the left, but we don't have a 0 in front of the 1. So don't go counting zeros like we did with the positive ones. All right, count place values. In this case, we went left 2 place values. Here we're going left 3 place values. And of course 4 place values to the left. and 5. 5 place values to the left. It's that simple. Now, let's talk about converting scientific notation of very big numbers. And I've already said very big numbers have a positive exponent. So the first step for writing a number in scientific notation is always the same whether it's a big number or a small number. The first thing you're going to do is you're going to take your digits, whatever they are, and you're going to turn them into a factor, a number that is at least equal to 1 but less than 10. So you're going to think about where can I put my decimal point that I can make a number between 1 and 10. And in this case, it has to go right here. Because if I put it here, we've got 13.5. That's not good. That's bigger than 10. If I go over here, 0.135 is smaller than 1. So it has to go right here. Usually what you're going to see, and actually what you can think about is there's going to be one digit in front of the decimal point and then whatever else you have to have after. Now, once we've done that, the next step is going to be counting how many places that we're going to use for our, that we've got to move it, and I'll show you what that means. But we're going to move starting here. This is where our decimal point is right now, and we are going to move it all the way over to here. Okay, we saw that on the last slide. We've got to put it there. So let's see how that works. We're going to count how far we've got to move the decimal point. So we're right here with the decimal point, and we're going to move it all the way over there. Let's see. We've got 1, 2, 3. These are moving kind of slow, aren't they? 4, 5, 6, 7, 8. And there we go. We moved 8 decimal places to get there. Okay, so if we counted them, 1, 2, 3, 4, 5, 6, 7, 8, that means that's our exponent. All right, so the number, this is our digit, our coefficient between 1 and 10, and we counted 8 places we had to move it to get it where we needed it. That makes it the exponent of 8. All right, now that you've seen an example, your turn. Count them carefully. Now, let's talk about making the tiny numbers. I said before, the first step is always to come up with our first factor, or we call that the coefficient, or we call that the digit number, whatever you want to call it, all of those are accurate. We want to come up with a number that is between 1 and 10, less than 10 and at least 1. So we look at our number and decide, where do I put that decimal point? Well, I can't put it after the 7 because that makes it 587. I can't put it between the 8 and the 7 because that makes it 58. That's bigger than 10. But if I put it right here between the 5 and the 8, that gives us 5.87. So that's going to become our first factor, our digit, 5.87. Next step is to count how many places that decimal point has to move in order to get there. So we've already decided that's where the decimal point has to go, right there. And we're going to come from here. Forget this 0 out in front. It's just sitting there because math teachers like them there. It looks pretty tough. So we don't start there. We start here counting. And here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. We counted 10 of them. It's a little harder with these because we don't have those nice commas that give us the groups of 3. So if it's 10 places, now remember we are talking about a tiny number, a very small number. So we've got to make our exponent negative. Okay? Our exponent has to be negative when we're making a tiny, small number. Okay, we've got a few here examples I just want to do for you. We're going to do them one at a time. Notice these two on the left are big numbers. So that means our exponent on our 10 is going to be positive. And I'm doing that 10. Now, take a look at our digits. Our digits are right here, 189. In order to make it between 1 and 10, I'm going to put my decimal point right there. Okay, so I'm going to do 1.89. And then I'm going to count. How many does it take to get to that spot? Okay, so I'm just going to count by threes. I like the big numbers because you can count by threes really easy. Your eyeballs don't get all mixed up. 3, 6, 9, 12, 15, 16, 17. Okay, let me do that again. 3, 6, 9, 12, 15, 16, and 17. And it's positive. Okay, let's do another one. Now look at this one. It's kind of a big number, but still, if I tried to put my decimal point here, 68 is bigger than 10. So I want to go here. Like I said, it's usually going to have it's always going to have a digit, then the decimal point, and then whatever else you need to include. In this case, we've got a little bit more to include. 6, 8, 9, 1, 4. All right, that's going to be times 10. Now let's decide. We want to put our decimal point here. So once again, easy counting. 3, 6, 9, and then I'm going to go from there to there. So that is 10, positive 10. Now let's do some tiny numbers. And they are more of a pain to count because they're not grouped nice in thirds or threes. I wish we used commas there. I don't know why we don't, but that would be nice, wouldn't it? All right, so we're looking at our digits. 5, 6. We don't pay any attention to any of the rest of that stuff for now. 5, 6. So we're going to put our decimal point there. So it becomes 5.6 times 10. Now remember, this is a tiny number, so we're going to have a negative exponent. That way, later, next lesson, you're going to learn how to go back the other way. But for now, that's the way we do it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, there we go. 14. That is a very small number. One more example. Again, take a look at our digits. That's our first step. Look at our digits. We've got 789. I'll write them down, 789. In order to make that between 1 and 10, I got to put my decimal point right there. And this is going to be times 10 to some negative exponent. Count them out one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, to the negative 13th. That is how you do that. Now it's your turn to give it a try. Okay, so we're going to take a little break here, watch a little musical. Enjoy.